Welcome back to Calculus 1. Last episode we explored one-sided limits and their importance. In this video, we'll go over some limit properties that better help us understand and solve limits. There are 8 main properties of limits. These can be thought of as a set of tools and techniques we can use to solve limit problems. We're not going to go over these individually. However, throughout this video, we will use these properties to help us evaluate limits. Feel free to take the time and pause the video and jot down the properties. This should help reference each property as we go along in the video. Ready? Let's get started. We'll first look at a polynomial. Let's find the limit as x approaches 2. The first thing we'll want to do is simplify this by splitting up the polynomial into less intimidating limits. We're allowed to do this by using property 2. Now we can evaluate these limits individually. We'll start with the first one, 3 times x squared. How about we utilize property 1 and pull this 3 outside the limit so we don't have as many variables inside. Now we have this pesky 2 in the exponent. Similar to property 1, the fifth property lets us pull this outside, leaving x by itself on the inside of the limit. Now we just have the limit of x as x approaches 2. Here we employ property 8, which allows us to directly substitute the value that x is approaching into the function. This gives us a 2, which is then squared, then multiplied by 3 to give a result of 12. Now we have 4 times x. Again, we can use property 1 to pull out this constant and evaluate the limit. Once again, using property 8, plug in 2, then multiply by negative 4 and get negative 8. And at last we have the limit as x approaches 2 is 6. According to property 7, the limit of a constant value is that constant. In this case, 6 is our constant and is the solution to this limit. Now we just have to combine the miniature limits together to solve for the main limit. Simple addition and subtraction shows us that the limit as x approaches 2 is 10. Let's look at a few more examples. Here we have a function in the form of a fraction. Let's try to find the limit as x approaches 0. The most essential property we need for this problem is property 4. This way, we can pull these functions out of the fraction, evaluate them as independent limits, then plug them back in. Let's look at the numerator first. Cosine of x is a continuous function, therefore we can use direct substitution to solve. If we recall from trig, cosine of 0 is 1. Now we can move on to the denominator. Again, this function is continuous, so we'll just use direct substitution. We have e raised to the 0th power, which is simply 1. Reassembling the fraction, we'll see that we have 1 over 1, which of course is 1. So, the limit of cosine of x over e raised to the x as x approaches 0 is 1. Let's look at one more example that utilizes the two properties we have yet to use. The function we're given is the square root of x plus cosine of x times sine of x, and we want to find the limit as x approaches pi divided by 4. To start off, we'll use property 2 to separate this limit. Now we can focus on the first term. According to property 6, we can pull this square root outside the limit and evaluate the internal function. Again, property 8 lets us use direct substitution to solve. This leaves us with the square root of pi over 4. This solves the square root of pi divided by 2. Turning to the other term, we'll see that we can solve this easier by using property 3. Much like some of the other properties, property 3 allows us to separate the limit, solve, then reassemble. In this case, we have two functions being multiplied together. After the functions have been separated, we can start solving. We can once again use direct substitution on these functions, and it just so happens that both limits give the same value, square root of 2 over 2. We can then multiply these together and then plug back into the main limit. In the end, we get the square root of pi divided by 2 plus 1/2. And that's all for this lesson on limit properties. Thank you to everyone that stuck around to the end of the video. If you enjoyed, don't forget to leave a like, comment, and subscribe for more videos. I hope to see you all in the next lesson.